All right, so we got a height that is translated -2 plus 3, -2 plus 3, so and then rotated. So what you have to do, and I know I don't ask you a ton to write down, but what you really need to do here is give the new coordinates of A, B, C, and D after this -2 plus 3. Okay, so the X values you're subtracting 2, the Y values you're adding 3.
All right.
All right, so the way that worked, you want to give me can you give me those new ordered pairs here?
So I think A would be -7, 4,
Okay, keep
and
going.
then -2, 5,
Okay.
or -4.
It's -4. Yeah, -4, 5.
And then -3, 4,
Okay, and then keep
and
going.
then -4, 3.
All right, very good. Now I'm going to snip in. I'm going to snip in the rule here. This is 90 degrees counterclockwise. Is that what that says? Okay. So here is the rule for that. I'm going to put that rule here. You have to step away for a moment, but maybe you can figure out the rule here. So the XY is what you're starting with, and then the -YX is what you're moving to, and maybe you can figure out the answer. I'll be right back.
All right. Let's see. -4, -7, -5, -4. All right. So it'd be third one.
All right, I am back. Any
I think it's number 3.
okay. So number 3, basically you're taking the X value, putting it in the Y position. So that's -7, -4, -3, -4. And then here you're negating the Y. So -4, -5, -4, -3. And that looks good to me.
Yep.
Right. Any questions on that?
No, that was pretty easy.
Yeah. So there's a whole rule of these transformations that I could send you. I might as well do that. Whenever I say I should do something, I should just do it. And you could print that out. It's one page. For some reason, your course seems to emphasize these transformations, but let's look at the next one here. All right, so it says it's rotated 90 degrees counterclockwise. 90 degrees counterclockwise. So that same transformation rule is right here. And
All right.
so see if you can use that. It's just interested in point A.
So point A is -5, -1. So if you would switch that, it would be +1, -5. Right?
Well, you tell me. A is -5, -1. So what is the rule here for 90 degrees counterclockwise?
Well, you have to flip it. And since one's already negative, it would be a positive, right?
Right. So which one is like basically we got to get out of like we're trying to transition on Matthew just doing the problems, you kind of giving a little more input here. Like what is the final answer here? Which one is it?
Um, Not sure.
Okay, well, you do exactly what you did. You take the y value and the positive one, and then then the
Well, I just don't see the answer there.
okay, so I'm sorry, it's positive one. That's what the issue is. Positive one.
Oh, okay. So it'd be which one? 1, 5. Wait. Oh, -1, -5. So it'd be 2.
Let me just, sorry for all the breaks here. I could just take a step away for 30.
Oh no, it's totally fine. Hmm.
All right, I am back. Apologize for the delay.
All
Let me
good.
know when you're there. All right. So the flip of this is -1 comma -5. Is that one there?
Yeah, so
Looks like it's B. Okay. Um, all right, so we're up to this next one here. All right, figure H is represented in the graph. Which series of transformations will not map figure H back onto itself? This is really tough. Like you have to, whenever it says which of the following will not, that means that 3 are true and 1 is false. Do you know what I mean by that?
yeah, I got you.
Okay. Which means when you look at these, most of these are going to work. So it's kind of it really is a process of elimination. So the first one, we'll just do the first one here. X plus 0, y minus 2. So that moves it down 2. So everything goes down 2. So it comes down here. And then it reflects over y equals 1, which is this line right here. So that one does go back onto itself. Do you see that? Do you agree with that?
Yeah. Yeah, I agree.
Okay. Okay. Now let's do the next one here. So the next one is you go right 2 with everything. So this goes here, right 2, and then reflecting over the line x equals 3. So it goes backwards to that one there. So that one is also out.
Yeah.
Then the harder. Like, so I mean, there's another strategy here. You try the easy stuff first, right? See if it works. If it does, you're great. If not, oh well. Now the next one here is right 3 and up 3. So right 3 and then up 3. So this point here, it's point by points. You'd go right 1, 2, 3, 1, 2, 3. So it's here. It's now right there. There's the new one for this right 3, up 3. And then we're reflecting over the line minus x plus 7. So they don't give you enough grid spaces here, but it ends up being this graph. Oops. Whoa, what happened there? It ends up being this line right here.
All right.
And so what that means is, like, does it work? Does that flip back over there? It sure looks like it does.
Yeah.
So we can say that, well, probably that one is okay. So must be the last one.
All right.
My process of elimination. All right. Any questions on that?
No?
Okay. Okay, so 180 degrees about the origin. I'm going to snip that one in as far as the transformation goes, and you can tell me what you think the answer is. So here's the rule. You can't do it without the rule. This is the rule for the transformation. Know that you're just interested in point A, so you only have to focus on point A again. Seems like we already did this.
It's just like a different way of
Oh, it's
doing it.
different. Yeah. Right, so I guess you do the transformation stuff and see what you come up with there.
Would it would be +5, -1.
Okay, so which answer?
Number 2.
Yes. Wrong one. All right, very good. I think that is everything you sent over. If you want to send over a couple more, we can get started on the next ones.
Sure, I got you.
Maybe you did send over. No, we did all those. I don't know. Is there any we didn't? No, it looks like we did do all of them.
All right, sending over a few right now. In order.
Good list there. Got a bunch of stuff sent over.
Yep.
All right. So here we go. Number 11, which series of transformation would carry the rectangle onto itself? So, ugh, boy, you really have to do all four of these to know. So I guess we can try that off to the side here. So the first one, x plus 0, y minus 4, means it's going down 4. So it's down here somewhere.
Yeah.
And then you 180-degree rotation puts that up here is a little bit higher, and then reflect over the y-axis to see it gets kind of there. I don't know. These are hard to see. I wonder if there is a transformation website. Have you ever used Delta Math before?
Nope.
Calculator.
Wait, is the question like asking would it like perfectly go back on itself?
Yes, that's to perfectly go back onto itself.
All
Yeah.
right. All right.
So the reason I was asking about Delta Math is they actually have that in there, this like thing where it'll transform and you can see it. You can't really see it the way I'm doing it. So this
Yeah.
other one, the only difference about this other one is it's x-axis instead of y-axis. So that's definitely out. All right.
Oh yeah, I was also gonna ask about that. Like, if you do the first one and it says y-axis and that doesn't work, is it like always not gonna work for the x-axis?
No, you can't make, have you ever seen Office Space?
No.
Okay. It's an older movie. You'd recognize some of the actors in it, I think. It probably didn't age that well, but it's got a guy in there. He's like, he made a jump to conclusions, Matt. Like literally something you would jump on and reach a conclusion. And that's kind of what you're doing here. You're jumping to a conclusion that you can't make. Uh,
All right.
like we want stuff like that to be the case, but it is not. So, all right.
Got it.
So the next one here is going down 4, kind of like we were doing last time. So let me do that here, and you really do want to do it more exact, but it's tough to do. So you're going down 4, so it's down here, and then I'm sorry, no, these are right 4. These are left 4. So you're going left. -4 is left 4. You're going to the left 4, left 4 there. And then reflecting 90 degrees counterclockwise rotation. Hmm. You know, I take that back. I messed up this first one. This first one rotates here, and then it does rotate here. So 4 down, this top left here goes to the top left there. Top right goes to there, bottom left, bottom right, bottom right. And then this has happened.
Oh. So it would work or no?
It does. So it ends up being the first one.
All right.
So I made a mistake here of thinking that it was shifted down lower than it actually was, but it's not.
Okay.
Okay. So I think we got another one here. Can look at. Triangle ABC is congruent to triangle DEF. So ABC turn to triangle DEF. Where's F? Oh, what's the coordinate of where's F?
Where is that?
Yeah, where is F? So the way to do this is to go point by point. So let's say we put a point at -2, 4 right there, and then we connect the triangles. Do these look congruent?
Mm, no, the
Yeah, I
other
would
one's a
say,
little taller.
yeah, that's good. Good eye on that. So then you go the other, you say, okay, that one's out. So minus 2, 3, and you draw kind of the same thing here. Does this one look, does this one look congruent?
Yeah,
Sure does. So that's probably our answer.
nice.
Questions on that?
No,
Okay. All right. So we got polygon ABCD is the first in a pattern. Transform the images A prime is at minus 2, 4, D prime. All right. So they're telling you where the new points are. They're telling you the new point A prime is, so it was 2, 4, and now it's down all the way down here at minus 2, 4, which we can't really even draw, but it was up here, and now it's down here. And then D prime, that's this one, the lower left, it's now at minus 1, 2, sorry, minus 2, 4. I'm going the wrong way. Minus 2, 4 is over here. And this D, this is A prime. D prime is now at minus 1, 2 right there. And there's kind of the axis. There's D and there's D prime.
all right.
So any ideas in that? Like what does it look like? I mean, it kind of looks like it's moved
It looks like it's
over.
reflecting.
Yeah. And that is probably the correct answer there. If triangle MNO is congruent to triangle PQR, which statement is not true? So MNO, PQR.
Oh,
Okay, so one of the things that's really important to do is to draw the triangles the same. They have to be the same orientation. It's a path when you draw the letters. It's a path when you draw the letters. Like they have to be the same path. Okay. Now, what is
yeah.
true? Here's what is true. We'll start with the easy stuff. Angle M is congruent to angle P. Angle N is congruent to angle Q. Angle O is congruent to angle R. The next thing has to do with the sides. So M to N is congruent to P to Q, and it has to be that order. M to N, P to Q.
I think I got a
Then,
guess.
then N to O is congruent to Q to R. R to P is congruent to O to M.
All right. I was thinking it was the first one
That is correct.
because like MN, it's like going up and then QR is going down. So it's like, it's not following the path.
Yes, and that's important. It's a path. It's like when you walk somewhere in a hike or something, you take certain turns here. So okay, the triangle DEF is rotated 90 degrees clockwise. So we don't look at clockwise, counterclockwise much anymore because we're all digital, but that's this direction. So that is the clockwise direction, CW for clockwise. They're asking, well, what is true? And it's like you got to figure out what matches up. So D matches up with L. F matches up with N. E matches up with M.
Second
All right,
one.
there you go. Yeah, I can't really read that, but you try to see it on your screen.
And I don't know why it does it. It does the same thing for me. I think it's just like naturally like
What kind of
background
browser
black.
are you, what kind of browser are you using?
Google. It's what I use for
Chrome.
school.
Okay, so there's no issue with that. I think it's the nightscape, if you're asking my opinion, the night mode, but
Yeah, I'm not sure you can change it on this website.
all right. So what additional information would you need to prove that triangle ABC is congruent to triangle BEF by SSS? So SSS stands for side, side, and wait for it,
So
side. Yeah, pretty creative. So all three sides have to be congruent. And right now, you only have two sides congruent. You have that AB has got a single line that goes with ED. BC goes with a single line ED. Take a look here. What do you see? What
um let's see. I feel like it would have to be AC and something else. AC and DF.
Okay. Is there any other, it could be AC and DF or AC and FD? Okay, so the order of the letters matters. So if you're going from A to Z like this, it means that you're going from like the single line to the double line. So which would that be? Is that FD or DF?
DF.
Okay, so there's your answer. And it's weird. It's one of those things like, what do you mean we can't like, no, you can't. You have to um, do it in the order that that it recommends here. This isn't good. All right. Okay. So let's see here. All right. I see you're sending a few more off. I don't think we
Yeah.
got all those in, but all right. Ebony is cutting dough for pastries in her bakery. He needs all the pieces to be congruent and is ensured that angle EF, I'm sorry, side EF, so E to F, and the order matters, E to F is congruent to O to N. Q to N, I don't know what that is. But the order matters. Sometimes you almost want to draw an arrow so you can see that. And we know that angle MON. So the way angles work is that middle letter is the vertex. Middle letter is the vertex, M to O to N. So that one there. It's a path again. M to M, start at M, go to O, go to N. It's congruent to G to E to F right there. Now SAS stands for side, angle, side, side, angle, side. Okay.
Yeah.
So that means that, well, we need another side. Now, what you don't know, or maybe hasn't been made clear, is that the order matters here. Like it has to be a side, then an angle, then another side. And so even though I've kind of created this path here, I was just showing you that the other side is this one on the other side of the angle. So it's M MO and EG that are the ones of interest.
All right.
So I want you to look at those answers. Do any of those stand out to you as being possible answers in this case?
MO to EG, you said? Or OM
MO
to
to
EG?
EG or OM. Yeah. Is there more than one, or is that the only possible one?
MO to EG. I don't see an MO to EG, but I see a OM to EF.
Isn't that EG there?
Was that a, oh yeah, that's a G. EG to OM. Oh, okay. I was reading OM to, or was it OM to EG, so I didn't see that one.
Well, let's see here. So I think that takes care of that one.
Yeah.
Go back to the chat here. How many questions are there?
25. So there's
Okay.
7 left.
Okay. Yeah, probably not getting them all done today, but we'll do our best. So here we go. If triangle ABC is congruent to triangle DEF, but it says, and okay, forget about that for a moment. So here's triangle ABC. And it says that B is a right angle. So that's A to B to C. Do you remember what the measure of a right angle is?
90 degrees.
90 degrees. Okay. And then they're telling you C is 42. You remember what all three angles add up to?
180.
So give me the missing angle here. That's not necessarily the answer, but that's what I'm asking you for next.
48.
48. Okay. So let's go take a look here. So here's the other triangle, DEF. Now the order matters. So A goes with D. So that means the top. E is down here at the bottom and F is on the right. So that's 90, 42, and 48. Which one are they asking about?
D.
D. So what is the correct answer?
48.
You got it. All right. So I mean, I get it. Like, yeah, these are moving through as quickly, but you're doing a great job. I get maybe that this is frustrating or you're not fully getting it, but you said you saw this once before. I mean, you saw this
Yeah,
year.
this was probably like the easiest part of geometry for me.
Good, good.
I don't know, it just
All right.
clicks.
So again, triangle ABC is congruent to DEF. All right. BE is 41. EF is 23. BF is 36. And BC is 4x minus 7. Right. So which two sides are congruent based on the way I've drawn this?
DE in EF and AB and
No, no,
BC.
triangle to triangle, triangle to triangle. Like I've drawn them exactly the same.
Oh,
A, C, D, E to F.
oh, A and D, and then B and E, and C and F.
Yeah, so maybe I'm being unclear. So this side down here is the same as this side over here on the right.
Oh, BC
So
and EF.
yeah, so 4x minus 7 is equal to 23.
Oh, my bad.
No problem. So why don't you try solving this for me and letting me know what you come up with?
All right. So you would add 7 on both sides, and it would equal 30.
Okay.
Then you divide 30 by 4 on both sides. You would
Okay.
get 6, 6, 12. Or no.
You
Uh,
use your calculator if you need to.
what is it? Uh, yeah, I need a calculator.
Go grab one and let me know when you got it.
7.5. Right, 7.5.
Right, so if you can try to have a calculator ready for us for our lessons, it does help on occasion when we run into the lightest of actual, algebra questions. Most of the time it's not very intensive. Okay, the proof is missing a reason down here, so we have to figure that out. So sometimes we could just kind of progress through the proof. It says the measure of angle ADE is 68. That's where the 68 is. Measure of angle DAE is 90. That's the right angle. Measure of angle AED is 22 degrees. So we can add that in the picture here. All right. And the reason it's 22 degrees is because the three angles in the triangle add up to
180.
180. Okay. So they're saying DE joins the midpoints of AB and AC. So what that means is that this is congruent to this, and this up here is congruent to this up here. DE is parallel to C. Triangle angle ECB is congruent to triangle AED. So what they're saying is that, I'll do that in blue here. This angle down here is congruent to this angle down here. And that's because the lines are parallel. All right. So what are we doing? It really comes down to the words. Typically, the next reason follows from the words there. So hopefully you see that mid points and mid segments are basically the same. And that's the justification for this right here.
Yeah, I was gonna say it, but
And like we talked about, sometimes they're just not even reasonable. Like this isn't reasonable, this isn't reasonable, this isn't reasonable. So
yeah.
but all right, we are going to stop here for today. So good job. Like I said, I'll get back to you on the